Hello, everyone. My name is Rally. And my animator name is... with study program. And her student ID number is... Have you ever wondered how computers can think and make decisions? Today we will discuss logic in computers. Let's get started. First, let's talk about how computers actually understand information. Here's the thing. Computers are actually incredibly simple creatures. They only understand two things: on or off, yes or no, true or false. In computer language, we represent these with numbers. Number 1 means on, true or yes. Number 0 means off, false or no. This is called the binary system. Think of it like a light switch in your bedroom. When you flip the switch up, the light turns on. That's a 1. When you flip it down, the light turns off. That's a 0. Now here's the amazing part. Everything your computer does, watching videos, playing games, sending messages, editing photos, all of it is built from just these two numbers, 1 and 0. Inside your computer, there are millions, actually billions, of tiny electronic switches that turn on and off millions of times per second. These switches work together using something called logic gates. And that's what we're going to learn about next. So what exactly is a logic gate? A logic gate is basically a rule or a decision maker. It takes one or more inputs, follows a specific rule, and then produces an output. There are several types of logic gates, but today we're going to focus on the three most important ones: and, or, and not. Let's explore each one with real-world examples that you experience every single day.
Let's start with the AND gate. The word AND is really important here because it means all conditions must be true for the output to be true. Let me give you some real-world examples. Facebook login. When you log into Facebook, your username must be correct, input 1, and your password must be correct, input 2. If even one is wrong, you can't log in. The system uses an AND gate to check both conditions. So remember, AND gate means all inputs must be 1, true, for the output to be 1, true. If any input is 0, false, the output is 0, false. Now let's talk about the OR gate. OR is different from AND gate, because with OR, you only need one condition to be true, not all of them, just at least one. Here are some examples you deal with every day. Getting notifications. Your phone buzzes when you receive a text message, input 1, or you receive a phone call, input 2, or you get a social media notification, input 3. Any one of these will make your phone alert you. So with OR gates, if any input is 1, true, the output is 1, true. The output is only 0, false. If all inputs are 0, false. The third logic gate is the NOT gate, and this one is actually the simplest. NOT gate just does the opposite of whatever the input is. It flips or inverts the signal. Let me show you some examples. Dark mode on apps. When light mode is active, screen is bright. When you toggle it, NOT gate in action, screen becomes dark. It switches to the opposite. The NOT gate only has one input and one output. It simply inverts whatever comes in. If input is 1, output is 0. If input is 0, output is 1. Simple as that.
And there you have it. Computer logic explained. Remember, computers speak in binary, just ones and zeros. And gate. All conditions must be true, or gate, at least one condition must be true. not gate, gives you the opposite. From these simple building blocks, we've created smartphones, computers, the internet, artificial intelligence, self-driving cars, and everything digital you see around you. Pretty amazing, right? Thanks for watching, and I'll see you in the next video.